Next, we're going to solve rational equation word problems. So we're going to follow the same step to solve word problems as we've done in the past. To remind you, that's step 1, define your variables. Step 2, draw a picture or chart if possible. Step 3, write an equation. That's the thinking step. That's where you have to read the words in English and translate them to algebra. Step 4, solve the equations. You're going to be using the same methods that we just used from this rational equations above. And then step 5, check your answers with the words, not with your equation that you wrote, but with the words, and then answer with units. So let's remind you about consecutive integers. If you ever have consecutive integers, you're going to let the first number be x, and the second number is just one more after it, x plus 1. Whereas if you have even or odd, the first number is going to be x, and the second number is going to be x plus 2. Even and odd seem like they're the same, but clearly they're different because the first number has to either be even or odd depending on which type it is. And then one other thing that you need to use for this is the reciprocal. The word reciprocal means 1 over. So the reciprocal of x is just 1 over x. On our first word problem, it says the sum of a number and its reciprocal is 29/10. What is the number? So I'm going to first let x be equal to my unknown number that I don't know what it is. Usually in the question or directive, it tells you what you're looking for. I'm looking for a number. Okay, then it also mentions a reciprocal. But like we just reminded you, the reciprocal of your number is going to be 1 over x. So this is step 1, define your variables. Step 2 says, can you draw a picture? Not on this one. Step 3, write your equation. The sum. Let's go back and read. The sum. When it says sum, I know I'm going to stop and write plus. Okay, let's keep reading to find out what we're going to be adding. The sum of a number. Okay, well that's the x. And its reciprocal. Okay, those are the two things I'm adding. The number and its reciprocal. So x plus, because of the word sum, the reciprocal 1 over x, is, do you remember what is means? That's equals 29/10. So I've got this equation. Don't forget that if you can at least get your equation, you're going to get some points on the test, because I'll be grading to see how far in the equation you can get. So if you can get the equation but you don't solve it, well then I'm going to give you at least credit for that. Alright, so the next step is to solve. I'm going to solve this like I've done all the other ones. The first one doesn't have a denominator, so one thing I like to do is just make it have a denominator so that I don't have to worry about treating it any differently than all of the other ones, so I'm going to put it over 1. The LCD between 1, x, and 10 is 10x. So I'm going to multiply every single numerator by 10x. Let's see what divides out. On the first fraction, there's only a 1 in the denominator, so nothing really divides out. So I have 10x times x, or 10x squared. On the second fraction, one of the x's divides out, and I'm just left with plus 10. On the third fraction, the 10 divides out, and I'm left with 29x. So this is quadratic because you have a little 2 in the exponent. So I'm going to get one side equal to 0. Which gets me 10x squared minus 29x plus 10 equals 0. I'm going to try to factor this. I'm not sure if it factors at the moment, but I'm going to try it. Let's try, I'm going to do it over here. 2x times 5x. Let's try 5 and 2. I always start at the bottom of my list, and then I don't put the two numbers next to each other that are the same. So when I multiply, I'm getting 25 and 4. And I need I need both signs are the same, and they're both negative. Alright, I got my negative 29 like I wanted. So my equation factors into 2x minus 5 times 5x minus 2. I'm going to set each of those factors equal to 0. So I'm getting 5/2 and 2/5 as my potential answers. Now I really have to go back and check just to make sure that these aren't extraneous, but often they aren't extraneous in word problems, but you just really have to check. So if I plug these back in, if I plug in 5/2 into the denominator, well, that gets me the first fraction is over 1, the second fraction is over 5/2, and then the third fraction is 10. Well, neither of those three things are 0, so that one works. And then if I plug the second one in, I have the first denominator is over 1, the second denominator is over x, so that's 2/5. The third denominator is over 10. Notice I didn't even care about the numerators. All I'm really checking is any of the denominators equal to 0? No, they're not, so I'm going to keep them. So let's go back and answer my question. Because this is a word problem, you can't just like box x equals. That doesn't actually make sense. We're the one that brought x into the problem, so we need to take it out and answer their question. The question is, what is the number? Remember, we were adding a number and its reciprocal. So if 2/5 is my number, its reciprocal would be 5/2. And 2/5 and 5/2 do add up to 29/10. Well, what if 5/2 was my number? Well, the reciprocal would be 2/5, and it still adds up to the right number. So if you're asking which number is it, well, it could be either one of these numbers because the reciprocal is just the other number, and then they truly do add up to the thing that we were looking for, 29/10. So either one of these numbers satisfies this statement. On our next problem, it says the difference of the reciprocals of two consecutive integers is 1/2. What are the integers? Whenever you see two consecutive integers, you're going to let x be equal to your first number and x plus 1 be equal to your second number. That's what two consecutive integers automatically tells you. Now, there's no picture to be drawn, but I think the hard part here is to try to write your equation. So it says the difference. Okay, when I get to the difference, I stop and I write minus. Of the reciprocals, so I'm taking the reciprocal of something. So I have a fraction over and another fraction. I'm subtracting two fractions. That's what reciprocal means. So if the first number is x, the reciprocal of the first number is 1 over x. If x plus 1 is the second number, then the reciprocal of the second number is 1 over x plus 1. So I am going to take the difference of those. So I have 1 over x minus 1 over x plus 1. That is the difference of my two consecutive integers. Is means equals 1/2. So this is the equation. It's got rational expressions in it, so I'm looking for the LCD. There's nothing to be factored in the bottom, which means I just need to have one of each copy. I'm going to take that LCD and multiply it to every single numerator. Please don't be lazy, write it to every single one of them. And on the first fraction, the x divides out, and you're left with 2 times x plus 1. Minus, on the second fraction, the x plus 1 divides out, and you're just left with 2x. On the third fraction, the 2 divides out, and I'm left with 1x times x plus 1. Let's distribute here. Let's see, adding the two numbers on the left, 2x minus 2x, adds to 0, and I just left with 2. Minus 2 on both sides to get one side equal to 0. This is a quadratic problem, so I need to factor it or complete the square or quadratic formula. This one factors fairly nicely. So I'm getting x is equal to -2 or +1. Now those are my potential answers. I say potential because I still have to check them, don't I? Let's see. If I plug these in to the denominator, let's check x equals -2 first. I'll get 1 over -2. Nope, that's not 0. Minus -2 plus 1. That's not 0 either. Equals 1 over 2. That's okay. Let's check the next one, x equals 1. That gets me 1 over 1. The denominator is not 0. Minus 1 over 1 plus 1. 1 plus 1 is not 0. Equals 1 over 2. Now I could go further and check to make sure that these truly do work. I'm not actually going to do that. All I really cared about is trying to make sure that they're not extraneous, and neither of them are. But these are not consecutive numbers, right? The question was, what are the two consecutive integers? Why are these not consecutive integers? Well, remember, like in our last time we did word problems, we solved for x. And so both of these x's are first numbers. So if my first number is -2, what is my second number? Well, it's just one more than it, or -1. So -2 and -1 are consecutive integers, and they satisfy this word problem. But what if my first value for x was 1? Then what is the second value? Well, that's one more than it, or just 2. So 1 and 2 also work as a solution for this word problem. You have two sets of possible answers, possible consecutive integers, whose reciprocals do subtract to be 1/2. So two answers there. Okay, so this next problem says the sum of the reciprocals of two consecutive even integers is 9/40. What are the integers? So I want to make sure that we remember that these are even integers this time, not just regular integers. So when I let x be my first number, then my second number will be, because it's consecutive and even, x plus 2. So those are the two numbers that I am looking for. Now I'm going to go back and read the problem again and see if I can't write an equation from it. Again, there's no picture to be drawn here, so we can skip that step and go straight to the equation. So I'm going to read right from the beginning. The sum. Okay, sum means add, so I know my equation is going to have an addition sign. Of the reciprocals. Okay, so I know what a reciprocal is. The reciprocal is 1 over. And what are we reciprocating? Oh, that's right, the two things that we don't know, the two consecutive even integers. So my first number is x, so that's going to be, the reciprocal will be 1 over x. My second number is x plus 2, so the reciprocal is going to be x plus 2. Then I keep reading. It says is. Is means equals 9/40. And now I have an equation. So this is a rational equation, and I need to find an LCD in order to get rid of all of those denominators and get them in the numerator. So my LCD looks like 40x, x plus 2. So once I have the LCD, what I'm going to do is multiply every single numerator by the LCD. So that should eliminate all of the denominators if we picked our LCD correctly. So the x and the x divide out, and I'm left with 1 times 40, that's just 40 times x plus 2, because the x's divide out. The x plus 2 divides out on the second fraction, so we have a plus 1 times 40x, it's 40x. And then on the last one, the 40's divide out, and I'm left with 9x times x plus 2. So I need to do a little bit of distributing and combining like terms here. Looks like I can combine 40x and 40x to get 80x on the left. And I want all of my values to be on one side of the equal sign. So because my x squared is already positive and it's on the right, I would rather keep him there on the right. So I'm going to subtract all of the terms on the left from both sides, which gets me 0, that's what I wanted. 9x squared minus 62x minus 80. Well, I don't think that that has a GCF, so I'm just going to go have to try to factor that. So I have 1x and 9x, or 3x and 3x. and 80, I have lots of choices here. So I'm going to try to have to multiply up to 62. Now 62 is kind of large, so starting at the bottoms might not help me this time, but I'm just going to go ahead and try it. So when I cross multiply here, I'm getting 24x and 30. In 24 and 30, let's see, I have to have one of each sign because my signs have to be different to get 62. I don't think so. It's got to be a whole lot bigger than that because I need to have opposite signs. Switching these around won't help, putting the 8 and the 10 in different places because they're both next to a 3. So let's try 8 and 10 again, but this time instead of with 3 and 3 on the front, let's try 9 and 1. If that doesn't work, then I can eliminate 8 and 10 and try the next set. So we have 72 and 10. Oh, look at that. I can get to 62. It's a negative on the 72, a positive on the 10. So this factors into x minus 8 and 9x plus 10. So I set each of my factors equal to 0 using my zero product property. So the two solutions I have are 8 and negative 10 ninths. Now, what were these things to begin with? They were two even integers. And an integer is a positive or negative whole number. So one of these answers just doesn't make much sense. Negative 10 ninths is not a whole number. We're not canceling it out because it's negative. This time we're canceling it out because it's a fraction, and integers can't be fractions. So the answer has to be 8 as my first number. So if 8 is my first number, what would my second number be? Well, I'm just going to take 8 and add 2 to get 10. So 8 and 10 are my two consecutive even integers whose reciprocal adds to 9/40. To check, I'm going to plug 8 into my equation, so 1 over 8 plus 1 over 10 is supposedly equal to 9/40. So the bare minimum check is just to make sure that all of the denominators are not equal to 0, and clearly they're not. Now you could spend a little bit more time trying to get at a least common denominator of 40. So I can multiply this one by 5 and get 5/40. I can multiply this one by 4 to get 4/40. And I could go further to make sure that 4/40 plus 5/40 does equal 9/40, and it's true. But I don't have to do that. All I really have to do is just make sure that the denominators aren't equal to 0.